execute. What will be the initial value and what will be the destination condition. And the second thing is the body of the loop. So body of the loop contains the content that we actually want to repeat for limited or unlimited number of time. Okay. Now this control statement is further divided, is further having like three different sections. The first one is initialization, where we will decide what will be the initial value for loop, and the condition. This condition will decide the termination when the loop will be terminated. And finally, updation. To move loop from a source to destination, we need to perform updation inside the loop. Now, in C, there are basically three type of loops. So we are having for, while, and do while. For and while are entry control loop where the condition is tested first before entering inside the body of the loop. The second one is do while where the body of the loop is evaluated first followed by the terminating condition. Okay. Let me show you like what is the functionality or the working procedure of these three loops. First of all, we'll start with the for loop. The for loop is an entry control loop. That means first of all the condition is tested and when the condition is true, then the control move inside the body of the loop. So until the condition is true, the body of the loop is repeated again and again. And when the condition becomes false, then control jumps outside the body of the loop. So the general syntax, please check it out here. We are having for keyword, then we are having pair of parentheses. Inside parentheses, we are having two semicolons. First semicolon divide the initialization with the terminating condition. The second semicolon just divide the terminating condition with the updation of the loop. Then the pair of curly braces. So if you're having more than one like a statement and the statement, then you must have to like put curly braces. If you're having only one statement and then statement and that statement is not a declarative statement, you don't require any kind of curly braces with the body of the loop. Okay. Now, the initialization is the assignment statement that set the loop control variable before entering the loop. So the conditional test is the relational expression which determines whether loop will continue or will exist. Now, please check it out. Here, initialization, uh, this is the first place to be execute when the control moves inside the body of the loop. So first of all, the initialization is performed, followed by the terminating condition. After terminating condition, the body of the loop is evaluated. After body of loop evaluation, updation is done. Then again, the testing condition is tested. Then control moves into the body of the loop. That means initialization section works only for one time when a control is moving inside the body of the loop. Okay. Initialization is performed only for one time in the life cycle of the loop. Again, the terminating condition is tested, followed by the body of the loop, then updation, then again terminating condition until the condition is true. The control remains inside the body of the loop. When the condition becomes false, then control jump outside the body of the loop. This is the whole procedure. Now let me show a small example on that. Please check it out. New, I'm creating a source code file. Let me save this file in PU and I'll name this file. That's the for loop demo.c. This is the extension of our source code file. Please check it out. First of all, the header files. After that, the entry point. 0. So I don't want to return anything to my calling environment. So OS is my calling environment. Okay, who is calling this particular function? OS. Okay, so please check it out. Int main return 0. After return 0, suppose I just want to print a set of statement for 10 times. Okay, so number of iterations are known. So the for loop is the best optimal choice. Then I'm creating a variable I. Okay, let me create one more variable j. Now here I'm using for. First of all, here we have to specify the initialization section. This will be the terminating condition followed by updation, and then the body of the loop. Fine. So first of all, we have to initialize our loop. So I is equal to 0 or I is equal to 1. Terminating condition is until I is less than equal to 10. This is a terminating condition. And here I'm performing updation. I'm incrementing the value of I by 1. So this I will move towards the destination. So all the part are very important. Initialization, terminating condition, and updation. And here the statement that I want to repeat inside the body of the loop. So printf, hello world. I just want to print the value of I as well. So percentage D, percentage D, and over here, and then comma value of I. Okay. So look at this. So I just want to repeat the statement for 10 times. So I is equal to 1. I1 is less than equal to 10. Body of loop will be evaluated. Then I will be incremented. Then 2 will be less than equal to 10. Body of loop and so on. Please check it out. Okay. So hello world. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as soon as the value of I will become 11, this loop will automatically get terminated. Okay. Now let me show you one more thing. Here I'm putting a printf statement in it. Okay. Then here the terminating condition and printf increment. Increment or decrement. We get updation, UPD updation. Let me put a slash in over there. And less than equal to 5. There, hello. What I'll mention body of loop. Body. Okay. I'm incrementing inside the body of the loop. And I'm initializing I is equal to 1 over here. Fine, so look at this. Here we are initializing. This is the terminating condition. This is updation. Okay. So this is like code will show you which section will execute how many times. So this is the initializing section and the terminating condition section, finally updation. If I run this code, look at this. Fine. So initialization is done only for the first time. After initialization, the body is executed, then the updation is performed. Again, the body, and between the body and the updation, here we are having like a terminating condition, or we can say like a here we are having to do one thing. What I'll do, let me put a printf. I'm trying to perform a printf option over here. Printf. This is I'll specify like C. Mobile. Let me show you one more thing. Okay, and slash it. Please check it out. Fine. So initialization only for one time, then the condition is tested, then the bot is evaluated. Again, the updation, the condition status, the bot is evaluated. Updation, condition tested, and bot is evaluated. This is actually the order. So initialization is done only for the one time, then the terminating condition is tested, then the body is executed, followed by the updation. Right? So this is actually the working of the for loop. So initialization section works only for the only once. Then the conditions tested. After condition, body is evaluated. After body evaluation, updation is done. So this is the working procedure of for loop. Okay. So you can execute a loop for like a limited or unlimited number of times. Suppose you don't know the terminating condition, still you can use for loop for that purpose. Let me show you. So if I'll specify like for, okay, I'm putting two semicolon and I'm specifying a value 1. Okay, it is not mandatory. You can like skip all this section, then the body. Okay, here what I'm doing, I'm striking one more character, char cap. Saying like this is just to clean the buffer, and after that I'm just printing a statement. Hello, hello world. Okay, after message, what I'm doing, I'm just asking for a character ch. Uh, here again, mf, uh, like let me put a slash over here. So, do you want to PRI to print this message AGAIN again? Yes or no? Fine. Scanf page C followed by the CH character. Now, if here CH is not equal to yes, so look at this. In this situation, the number of iterations are not known. Let me show you. Let me run this code. Look at this. We are getting a message. Hello world. Do you want to just print this message again? Yes. Look at this. How many times I'll specify yes? The loop will repeat. Okay. Now what I'm doing, I'm specifying no. Now the loop get terminated. Okay, this is how we can execute a loop for unlimited number of times. So the number of iteration is not known. If the number of iterations are not known, you can skip the initialization and terminating condition part. Okay. So we don't know the number of iterations. So I'll skip the initialization, terminating condition updation. So it is actually a loop without any terminating condition. And what we are doing, we are testing the condition inside the body of the loop. This loop will execute until user pass any character other than yes, other than y. Fine. So it is a loop without any condition. Okay. So this is what we called. This is how we can like evaluate a certain statement again and again for unlimited number of time. Okay. And now there may be a situation where we are having loop. So please check it out. If I light for we have initialized value of I outside, okay? And here what I'm doing, I'm just writing I is a less than equal to 10 and increment. Fine. And then I'm putting a statement printf like a percentage d, comma, and the value of I. Okay. What I'm doing here, let me put a backslash n over here. It's the line number. And look at it, please check it out. This is the for loop. If I run this loop, so this statement will be printed, value of I will be printed for 10 times from 1 to 10. Okay, this is the general output. Let me do one thing. Now I'll put a semicolon after this initializing section. Okay, can you please guess the output in this case? A very simple question. Please check it out. Now what I've done, I've put a semicolon just before the body of the loop. So what will happen in this case, and what will the output? Any one of you? Nothing. Definitely we'll get some output. We are having a print statement in our code. Will this print statement work? Absolutely correct. Fine. Absolutely. Here, it is a bodiless loop. It is a bodiless loop. Okay, loop without any body. Right. So this loop will evaluate internally. And when the value of I will become 11, the loop get terminated, then control come to the next statement and it will print the terminated value of I. So it will be 11. And so the output will be 11 in this case. So now this section doesn't belong to for loop. Why? Because this is a loop without any body. We have terminated the definition of this for loop at the end of the syntax. So it is a bodiless loop. So bodiless loop are many times convenient when you want to perform a delay between the statement. Let me show you what is the use of this bodiless loop. The first use is to evaluate the final value of a variable. Okay. And the second important point, you can use this loop as a delay in your code. So I'm using for and I is less than 5 and I plus plus. Okay. And I'm putting one more loop inside it, like for I j is equal to 0 and j is less than, I'm like taking a bigger value. What I'm doing, I'm just trying to kill some CPU cycles over here and j plus plus. Okay, so this loop will do nothing. It will simply engage your CPU for some moment of time. Then printf like hello world. This loop will just give you a delayed functionality. Slash n over here. Let me increase value fun. Okay, so this loop, internal loop, is just to kill some CPU cycle. Now this program will give you a delay effect. Let me show you the code. Look at this. We are having a delay effect. Let me increase one more zero over here. Let me increase one more zero. Just a minute. Look at this. We are having a delay effect in our code. Look at this. Fine. So this is a borderless loop that is actually killing some CPU cycle before printing the statement. So this loop will evaluate, and this loop will engage your CPU for some moment time. Then the statement will be printed. Then again, this this loop will generate some delay. Then it will print the statement on the screen. So this is how we can use these borderless loop in our code. Okay. Fine. Just like for loop, we are having while loop in our code. So the visibility of for loop is better than while. So you can just check out the initialization, terminating condition, updation in a single line. But we are having one more option. We can also have while loop. So, while loop is just like for, but the syntax is a bit different. While, okay, and here I'll specify the terminating condition I is less than or equal to 5. So I'm incrementing the value of I by 1. Look at this. Fine. So here we are testing the condition. We have initialized our variable, counter variable. This is the terminating condition, and this is the updation, just like our for loop. The effect will be same. Fine. The effect will be same in this case. So this is how we can use while loop. The same way we are having do while loop. So do while loop, so this is a bit different. First of all, the pod is evaluated. Okay, and here we have to specify the terminating condition while I is less than equal to 5. And don't forget to put a semicolon. So here look at this. The condition is for the mod is first evaluated, followed by the condition. Okay. So if I want, I can just increment. Doesn't matter. Please check it out. Fine. Okay, but just remember one thing: if the value of I is greater than 9, look at this. The condition is false, but still this loop will work for one time. Okay. This type of loop are basically used when you want to evaluate the body of loop at least one, just like in menu-driven programs. Okay, so this is how we can use loops. So loop are very convenient when we have to repeat a set of statement for multiple number of time in a single location. Right. After loop, the second topic that I want to cover is the storage classes. Okay. So we know the purpose of data types. Data type are convenient in determining the type, size, and operation that can be performed on a variable in memory. In the same way, we are having operators. Operator just convert data into information. If you don't have any like operator in your environment, so data always remain data. It will never get converted into information. Again, now we are having storage classes. So storage classes is a concept that decide the scope and lifetime of a variable in a programming environment. Scope means from where we can access the value of a variable, and lifetime for what time and what amount of time the variable will able to memorize its value. So two important things can easily be decided with the help of storage classes. Okay. So in C, as you all know that we are having four storage classes. The first one is automatic or auto. Second is register. The third one is static. Fourth one is the external. So let me just start over. Okay. The four property that are decided by the storage classes are the first one is scope, the lifetime, followed by the initial value and a storage location. These are the four property that are decided by the these storage classes. So, first of all, we are going to discuss automatic. Okay. So, the scope of our automatic variable, as you know, that is local where the variable is created. For example, if I'm having a variable inside a block, look at this, I'm creating a block. This is just an anonymous block. Anonymous block means block without any name. But whenever we include an anonymous block, always a new scope is created in C. I'm creating a variable in I and its value is equal to 10. And look at this, we haven't specified any storage class before the name of the variable. So if we'll not specify the like storage class before the variable name, by default the variable is of type automatic. So the default storage class is automatic in C. So if you want, you can apply this auto. Okay, but by default, the storage class is automatic. Okay. Now look at this. We are having an automatic variable inside this block. Now what I'm doing, I'm just trying to like print the value of I. Okay. So let me save and compile this code. Look at this. We are having an issue. Why? Because the scope of the automatic variable is only inside the scope, inside the block where it is created. That means you can use the value of I only inside this shaded region. Okay, outside this block, you cannot access the value of I. Okay, so automatic variable are by default local to that particular area where they are created. Okay, so scope of automatic is local, or we can say local to the space where they are created. Okay, so see a local inside block, local, local to block. And these are also known as local variable. Now, lifetime. So when this block is executing, you cannot, when this block is executing, only for that particular time, this I will able to maintain its value. Once the block completes execution, you cannot access the value of I. Let me show you first of all Look at this. Now what I'm doing, I'm just putting the statement inside the body of this block. Now you are able to access the value of I. Okay, look at this. So this is what we call the scope. Now let me show you lifetime. Now what I'll do, I'll just put this statement inside another function. Okay. Now we are having these two statements in a different function. Please check it out. So this is a bad programming practice to do multiple line in a single state. This is not a good programming practice, but just to like save this screen area, I'm just doing this task. Okay, now please check it out. Here we are having a function named test. Okay, this function have two statements. First of all, what I'm doing, I'm just creating an automatic variable inside test, and then what I'm doing, I'm just printing the value of I. Okay, now I'll just create a loop over here. The for loop for I is equal to 0 and I is less than 5 and I plus plus. So what I'm doing, I'm just trying to call this a test function for 5 times. We are having only one statement, that's why we don't need to put. Okay, let me do one thing for the sake of clarity. I'll put this statement inside the curly braces. Okay, please check it out. Am I audible? Nisha, please turn off your videos. Okay, fine. Please check it out. So here we are having a function named test where we have initialized the local variable and I'm printing that value of that particular variable. Let me put a slash n over here. What I'm doing means from main, I'm just executing this loop for 5 times and I'm trying to like call this test function. And after the statement, what I'm doing, I'm just trying to increment the value of I by 1. So I'm initializing I by 10, then I'm printing its value, then I'm trying to increment the value of I by 1. Okay, so my intention is to increment the value of I between the function call. Okay, so please check it out. If I'll run this code, so please check out the lifetime. So we know that whenever we call a function, whenever we call this test function, the context switching will occur and control will jump inside the body of test function. Inside test function, this variable will be created, and the value will be printed. Then the value of I will be incremented, and after incremented, so when all the tasks inside this function are completed, this function is popped out of stack, and during the popped operation, all the local variable automatically get destroyed with the body of the function. So what will happen? So I'll call this test function for 5 times. So this I will be initialized for 5 times. The value of I will be printed for 5 times. I will be initialized for 5 times. And after performing the operation, I will be removed from memory because it is a local variable of the function. And local variable are created whenever they are called and destroyed when the function is popped out of stack. So look at this. So here, this I will not be able to maintain its value between the function calling. Okay. So what is happening? So when I'm calling this function, so I get initialized in memory, its values will be printed, and then I'll get incremented. And after performing the operation, the function is popped along with the function. All the local variables automatically get destroyed. So we are unable to maintain the value of I between function call. Why? Because this variable is local. So it's lifetime until the control is inside the body of the test function. When the test function like completes execution, all the local variable automatically get destroyed. That's why we are getting only 10. Okay, so scope is until the function is in execution. So for what will be the lifetime? So until the function is in execution. Okay, so this is the lifetime. Now initial value. So initial value of automatic variables is garbage. Let me show you the initial value. For that purpose, what I'll do, I'll just create, let me comment this out for now. Want this function to test all the other storage classes. So I is equal to 0, I is less than 5, I plus plus. Uh, okay, fine. Now let me create some more variables. I, comma, j. I'm not initializing them. Please check it out. I, j, k, l, m. Fine. We make them automatic. By default, they are automatic in nature. Now what I'll do, I'll just try to put the value for this variable. F I is equal to percentage d. J is equal to percentage d. L is equal to percentage d. I'm just trying to put the value. Figure out the initial value. I haven't initialized them. I'm trying to put the initial value of these variables. So look at this. We are having some garbage value inside this variable. That means by default, local variable contain garbage data inside them. So if we'll not initialize them, they will be garbage. So initial value will be garbage. Okay, and store those locations inside RAM. So if we are able to like store a variable inside RAM, definitely we are able to access the memory address. We are able to access their memory address because if the variable is created inside the RAM, we can access memory address. Definitely we'll get some addresses over here. Fine. So we are able to access the address of all these variable. That means that they are stored inside the RAM. Fine. So this is all about the automatics. Automatic, it is local to block. You can access the automatic value inside the block where they are created. Lifetime until when the function is in execution, until the block is executing. Okay, initial value is garbage and stored locations RAM. Now, second, we are having registers. So there isn't any difference between automatic and registers. So instead of automatic null specified register. So what is the advantage of register? These are the variables that we can maintain inside the CPU register. So we know that CPU have its own accumulator that it actually used to like put some data for faster processing. Suppose you are using uh, a variable like a counter variable inside your loop, which is frequently executing in your environment. So what we can do, we can put such type of variable inside the CPU registers. Okay. So how we can create, like how we can assign like variable, how we can assign CPU register to variables just by putting this register keyword before while declaring the variables. And just remember one thing, this register keyword is just a request, it is not a command. If your CPU will have space in accumulator, only in that situation, this variable will get memory. If the CPU is not idle, if CPU is not idle, these all variables will just treat like the automatic variable. Okay. Now, all the properties of a CPU of register variable are same. So, the scope is local to the block. Its lifetime is until the function in execution. Okay. Lifetime is also same. Its initial value is garbage, just like and storage location is CPU register. It just depend on the availability of register. If the register is not available, if the register is not empty, in that case, the register variable will treat as uh, a automatic variable and it will take space in RAM. Okay, but generally these variables are stored inside register. It just depend on the amount of space available in CPU register. If the register is free, then the variable takes space in register. If it is not free, then it will be treated as an automatic variable. Look at this. If a variable is register, so we know that we cannot access the memory address of register. So this operation is illegal. If I try to compile this code, look at this, we are getting issues. Why? because we cannot access the memory address of the registers, and here we are getting the issue. Address of a register variable I is requested, right? So registers, we always create register variables in register if a variable is frequently executing in our environment, just like our counter variables. So if you are using a variable I in a for loop and a loop is executing for a million times, so better to create that variable inside the CPU register for frequent execution. Okay. Now the third storage class is static. Static uh, is almost like the automatic. Only the lifetime of storage static variable is throughout the program, throughout the application. So look at this. So static variable are just like automatic. Let me make it static. Okay. So now if I try to print the value of I, okay, just remove this I for now. What I'm doing, I'm just trying to access a value of I that I've created inside this test function. It is not possible. Why? Because static variables are local. Their scope is local. They can access only within the region where they are created. So this definition, only this functionality is just like the automatic variables. So if I run this code, definitely we'll get a compile time error because I is not available in the scope. If you want to access the value of I, you must have to put the statement inside the body of this particular function. Okay, now you will be able to put the value of I. So just a minute. I haven't called this function yet, that's why. Yes. Please check it out now. I will be able to access the value of 5, 10 and 10. Okay. I think, okay, we are having, okay, let's remove this one for now. Please check it out. Fine. If you try to print the value over here, start the function call, you'll get an error. Okay. Because this I is inside the scope of test, so we cannot access this outside the body of test. So scope is local. Okay. Second, look at this. If I'll not initialize it, by default, the initial value is 0 in this case. So the the initial value of static variable are by default 0. Okay. Third important point, memory location. They are stored in RAM. That's why we can access their memory addresses. Fine. So we are getting a proper memory address. That's why that means they are stored in RAM. So only difference is in the lifetime. Let me copy this statement in static as well. Fine. So until is in execution. Initial value is garbage, not garbage, it is 0. And storage location is RAM. Okay. Only difference is in the lifetime. Okay. Suppose you want to maintain the value of a variable between the function calling, always make them static. So what I'm doing, look at this. I'm creating a variable I, and I'm using a for loop for I is equal to 0. I is less than 5 and I plus plus. Okay. I'm just calling this test function 5 times. Now just remember one thing. This I block, whenever we create a static variable is initialized only for one time during its lifetime. Okay, let me initialize it by one time. So whenever we call the static variable is created in a separate memory area. Okay, so whenever we create it, it is initialized only for one time. Okay, now what I'm doing, I'm printing the value of I. After that, I'm incrementing the value of I by 1. Okay, so what will happen whenever we initialize this variable will take space outside this outside the, we can say, the call stack. That's why its value will be maintained throughout the lifetime of your application. Okay. So what will happen when we call this test function for the first time? The static I variable will be initialized by 10. Then its value will be printed, and then it will be incremented. Okay. Next time when you call test again, this I will memorize its previous generated value. So you can just you can just maintain the value of this variable between the function call. It will make it static. So what we are doing, we are just assigning resumable capability to this variable between the function call. Okay, so please check it out. Now we'll get the effect of increment. Look at this. So static variable, just let it do the memory is same. Let me remove the address. I'm just trying to print the value associated with this variable. So look at this. Between the function call, this I is able to memorize its previous generated value. Okay. So hence, look at this. Here the variable is created in a different scope. So whenever we call this test function, okay, the first time it gets initialized by 10, then its value will be printed and then it will be incremented. Okay, after increment, this I will memorize its previous generated value. So when we next time we enter inside this block, this I will print its previously generated value. So this is how we can maintain the value of a variable between the function call with the help of the static keyword. So the lifetime is throughout the application, or we can say until the program is executing. So the rest of the property are same, just like the local variable. Okay, so local to block, your lifetime is throughout the application. So once it is initialized, you can it memorizes value. After that, its initial value is 0 and stores location RAM. Okay. Finally, the external storage classes. External storage classes is basically used to access the variables and functions that are created in a different file, and you want to access them in a different files. So if you want to share information of a variable throughout your application, you always have to make them external. Okay. So just let me show you how we can use external. So what I'll do, let me just remove this function for now. Extern, its scope is global. So it is global for the application. Lifetime until your program is executing. Until program is in execution. Okay, its initial value, if it is numeric, then by default it is 0. Stores location is RAM again. Now let me create one more file, source file. I'll name it GLOBALS globals demo.c. Okay, so let me create some variable over here. So int GLB is equal to, sorry, it's a GLB is equal to 1000. I'll create one more function. It's a void create message star. Hello, and the percentage S, then one name. The file over here, hash dio.h. Look at this, we don't have any main. Let me just compile this code for now. We'll get issues. Hash include. Let me save this one and fine. Okay, now I'll just move to that this for loop demo. And now I just want to access this GLB variable and this grid message. Okay, so now what I'll do, I'll just create external GLB. Okay. After that, what I'll do, let me put external into GLB. That means I'm having an external variable GLB somewhere in the scope. Now I'll print f its value percentage D. GLB is equal to GLB is equal to percentage D. GLB. Okay. Now what I'm doing, I'm just like including this global demo.cno environment. So I'll mention hash include within double quotes. So if the file is in the same folder where you're having your source code file, you can use this double quotation. And then globals demo.c. So GLO GLOBALS globals demo.c. GLOBALS GLOBALS demo.c. So what I've done, I just included this file in my code. So let me save this one. I'll try to compile this code. And look at this, we are able to access the value of that global variable, which is in a different file. Okay, let me remove this and from. Look at this. If I run this code, still it is working. So this keyword tells your program that GLB is a global variable which is defined somewhere outside the body of scope of this particular file. Right. So this is how you can. In the same way, you can access the function as well. Now here I'll specify exter, and then function declaration is, let me copy this one for now. Okay. So this is just a function prototype, and the function is defined inside the global demo. I just want to call this grid message. We are having grid message. Now I'll specify a name over here, like James. If I run this code, look at this. We are able to access the value of that particular function as well. The function is defined in a different file, and we are able to access that function in a different file. Right? So if the size of your program is very large, so you can just divide your program to different file, and if you want to use them, you can use this extend keyword to include that function or a variable in your code. Fine. So functions are by default external. If you want, you can skip this statement. Still, your program will work, but you will get a warning. So it is working. But, let me show you. Okay, let me compile this code. Just a view, coding report window. Okay, look at this. We are having a warning, right? The code is still working, but we are having a warning. Why? Because we haven't put external keyword. But if you put the external keyword, this warning will be resolved. Right? So functions are by default external in nature. If you want, you can include this external. If you include external, you will not get any warning sign. Okay, but for variable, you must have to put external keyword where you want to use that global variable. Okay, so these are the 4 different storage classes. Getting the idea? So these storage classes decide the 4 property of a variable. The first property is scope, second one is lifetime, third is the initial value, and the fourth one is storage location. So automatic register starting external. So automatic scope is local to the block. In all these 3 cases, scope is local to the block. That means you can access the value only the place where you have created the variable. In case of external, it is global. Lifetime, automatic, when the control inside the block. Same as in case of register. Okay, but in case of static, it is throughout the application. Okay, in external, the variable can maintain its value throughout the application. Initial value of automatic is garbage, register is garbage. In case of study next one, it is 0. Register's location. In register, it is only register. In rest of the cases, it is your RAM. So these are the like storage classes that decide the scope and lifetime of a variable in a C environment. Okay. So we have like done with the storage classes part. Now, the third important topic that we are going to cover today is the functions. The functions are very much important. Just let me just give you a quick review of functions. Okay, 1 minute. I'll just create a new file. Okay. So hash include in. Okay. Look at this. So we are having a function. So as we know that function are very much convenient when we want to repeat a set of statement again and again in a different location of our application. Okay. So there isn't any concept of reinventing the wheel in C. If you are having a function in your environment, you can utilize that function in any other part of your application. So this will reduce your code size. Okay. So debugging of your code will become easy. Okay. So in the same way, uh, the complexity is reduced in your code. So function have lot of advantages. Okay. So while using the concept of function, you can reduce your code size. So testing will become easy, debugging will become easy. So overall, the implementation of code will become easy. Okay, along with some advantages, there are a few disadvantages of function as well. So as you all know that whenever we call a function in our environment, context switching will occur. Control jump to the different function. So the function will be pushed into the stack, or the locals variable of the called function are put into the stack, and after operations, the function is popped out, and control will just come back to the calling environment. So this is a bit overhead, okay? But in most of the cases, the function is advantageous. Now, let me show you a small syntax, or we can say a smaller that we call it standards that we always use to create function in C environment. So function can be divided into 4 different category according to their signature. Okay, so sometimes we are having a function that doesn't return any value. So name of function is suppose add. We are having two argument. We are having haven't any argument. Look at this void. And what I'm doing, I'm just taking the value of a function over here, like let's give you a brief idea. Okay, num1, comma num2, and scanf. Okay, yeah, I'm printing is equal to percentage d. Right. I'm calling this add function. So look at this. A function that doesn't accept any argument and doesn't return any value. Okay. So argument is actually a kind of help that is provided from the calling environment. Sometimes a function requires some external help in order to perform its operation, this help, or we can say these values can be supplied to that particular function from its calling environment. Here, this function is totally independent. It doesn't accept any argument and it doesn't return any value to its calling environment. Okay, so it's a function. Its return type is void and it doesn't accept any argument from the calling environment. Now let me call this function add. Okay, so look at this. I'm just calling this function. So definitely we'll get the output. This program will ask for two values. Now I have to specify two values and look at this. So all the operations performed inside the body of this function. This is the first approach. Okay. Let me show you one more way by which we can like solve this function. So now let me do one thing. Copy this code again. I'll place it over here. Okay. And let me comment out this code for now. Okay. I'm having one more function. This function is returning a numeric value. That means, so what output is generated by this function, I just want to utilize that output in the calling environment. Okay. So instead of printing the data inside the body of this function, I just want to use this generated output in any other part of our application. So what I can do, instead of printing the statement, what I can do, I can just return this value to the calling environment. Okay. Now look at this. Now, while I'm calling this add function, whenever we call this add function, so context switching will occur. Control jump to the body of add. This add will create two different variables. After that, like we are like getting information from the user. Then I'm performing the operation, and finally I'm returning the data. So add is returning a numeric value. Okay, so at this particular point, this add will return its value. So what we have to do, we have to print it. So what I'll do, instead of putting a print statement inside the body of add, I'll put it inside the body of the main function. So here I'll just call add function. Okay, so look at this. This is a function with the return type without argument. Okay, still we'll get the proper output. 12 and 13. We are getting 25. Okay. So there is some situation where the calling environment want to pass some values to its function. Okay. So I don't want to like get value inside the body of the function. The function want to send some kind of value for computation to its function. So instead of like putting a scanf inside the body of add, what I'll do, I'll just take input inside main, and then I'll send these values to the add function. Okay, so here add have to perform some operation inside its body. Okay, now this function only perform the computation. We are providing information to this. We are providing like value to this function to the argument. Okay, so what I'll do. So look at this. Here I'm like taking input inside the body of main. Now my task is to send this value to the function for computation. Okay. Now what I'll do, I'll just pass num1 and num2 to this add function to the parameter. So these are the actual parameter, and here we need like some variable to hold the value that is provided from the calling environment. So this int num and num2 are formal arguments. Okay, so the name of these argument can be same, okay, or different, whatever you whatever requirement is. So you can just okay. So look at this. This num1 and num2. This num1 and num2 is the local variable of this main, and this num1 and num2 is the local variable of this add function. Fine. So now what I'm doing, I'm just passing information to this add function, and add function is holding the value being sent by this main function inside these local variables, and finally it is performing the operation over here. So this is the function with argument and without return type. Okay. Here, look at this. Okay, so instead of printing data over here, we are printing information over here. So now if I run this code, look at this 12 and 13, still will get the same output. Oh, just a minute. We are not printing it. Sorry. We have to call the function. That's it. Okay. Function with argument without print type. And the fourth category is function with argument and with print type. Just want to make a small change over here. I'll specify int over here, and then instead of printing the output, what I'll do, I'll just return this value. I'll cache that value. Page D, comma, value, fine. Okay. So these are the four different ways. And please check it out. Here we are having like four methods. Let me change their name. Let's add one. So we cannot have like a multiple function with the same name in C environment. I have to make a slide changing the name of all these functions. We don't have any concept of function overloading in C. That's I have to, okay, look at this. Now the readability of this code is not proper because I'm able to view only two functions. I'm not able to like view the main code. So we are having a programming practice. So when you are having a user-defined function, always create these function at the end of your code. Okay. You must have to put this main function at the top of your code. Now, like put the prototype of all these functions just before the main. Okay, so this will give you a better readability of your code. With the help of prototype, we can easily check it out that how many function we are having inside this source code. So what I'm doing, I'm just putting prototype over here. Okay, now it is very clear that we are having like a four function in this code. The first function doesn't accept any argument, doesn't return any value. Second, return a value but doesn't accept any argument. Third one, doesn't return a value but accept two argument. The fourth one, return a value and accept two argument. Okay, and this is the body of the main. So these are the function prototypes. Okay, and this is actually the function calling. And these are the definition of the functions. Right? So if you want, you can just remove these variables. It doesn't play any role in prototyping. Right? So this is how you can work with functions. Right? So this is all. Okay. After function, I just want to discuss uh, one more important topic in in C. That is the concept of arrays. Fine. Okay, so let me do one thing. We'll discuss the function a little bit later when we'll work with pointers, right? Now the next topic I want to discuss is the arrays. Okay, so hash include. Okay, fine. So suppose there is a situation where I just want to like hold data of a similar type in our environment. Okay. Suppose I just want to hold the percentage of 5 students. Okay. So first approach, what we can do, we can just create 5 different variables. Suppose I want to hold the marks of 5 students. Okay. So ST1, ST2, ST3, ST4. So I just want to like assign marks to these 5 students. So look at this. So all the variables are of type integer. So to assign values, so definitely have to scanf. For 5 variables, I need like 5, 5 access access mod. I just wanna comment specify 1, 2, 3, 4, and 5. Okay. Now again that approach percent st1 and percent st2 common and 5 variables. In the same way, suppose I just want to increment the value of all these student or marks of all the student by 5. So what I have to do? I have to write st1 plus is equal to 5, st2 plus is equal to 5. Look at the operation is a bit complicated, right? So please check it out. Fine. Now I just want to print the value of these students again. Okay, so please check it out. I have to like put the statement slash in the printf. Just a minute. Okay, here I have to like remove. Look at this. So these variables are individual. So we have to treat them individually if I want to perform some kind of common operation on these variables. So all the variables are of type like integer, right? So and all the variables are individual entity. So if I want to perform common operation on all these variables, we have to perform them one by one. So here I'm taking value one by one. Here I'm printing the value one by one. Here I'm incrementing the value of all the variables by 5 one by one, and so on. So the first issue is that if we are having like a 50 or 100 common values, so we have to create 50 and 100 different variables to hold these values. So this is the first disadvantage. And second, if you want to perform some kind of common operation on all these variables, you have to write a lot of code over there. Okay. So for such type of situations, whenever we want to deal a group of objects as a single entity, we have to use the concept of arrays. Okay. So array is actually a data structure that can represent a multiple variable of same type under a single name. Okay. Suppose I want to hold the marks of 50 students. So what I have to do, I have to write int, then any name that you want to give, like STU, then you have to specify the size. And just remember one thing, array are static in nature. Okay. Once I array is stored in memory, it cannot be increased or decreased at runtime. Second, it can hold similar type of data element. Okay. And all the element are contiguous in nature. So whenever we allocate memory to array always provide contiguous memory to all its data. Fine. So these are the 3 important properties. So I want to hold like 50 students. I have to mention 50 over here. Now, STU is an array that can hold 50 different numeric value inside it. Okay. Let me make array small. Please check it out. I'm having integer array of 10 element. So by default, look at this. It is a automatic type of variable. By default, it will hold garbage value inside it. So we are having like 10 blocks of 4 byte each because the size of integer is of 4 byte in dev C. Okay. So we are having 10 elements. So if I like printf percentage d, so this single variable is equivalent to 10 integer variables. STU. So please check it out. So just now the size of integer is 4 byte. The output will be 40. If we execute the same expression in dev C plus in turbo C, we'll get 20 because they're the size of integers of 2 byte only. Oh, sorry, just a minute. I have to specify size of. Okay, look at this 40. 4, sorry, 4 to 10 to 40. So the size of integers is 4 byte, and we are having 10 integers. So this array will acquire 40 byte of memory. Okay. Now, remember one thing. So we are having 10 different values. Let me print them one by one. So I'm using a integer variable for that purpose. So for I is equal to 0 and I is less than 10 and I plus plus. Okay, so we are having 10 variables. So I'm just going to perform this retrieval operation for 10 times. Printf. Now the percentage t, comma, and then I'll specify stu of. So to remember each variable individually, we are having an index, unique index. So index are always started from 0. So you'll get the element, first element always at the index number 0, and last element at the position of length minus 1. So if you're having like 10 array of 10 elements, so the last element will be at index number 9. Okay, so length minus 1 position. So look at this here and put here. And look at this, we have to initialize this array, so we'll get some garbage data in this array. Look at this. So we are having 10 location and every location has some garbage data inside it. Okay. Now let me initialize this array. So if you initialize a single element of your array, all the element will automatically get initialized by 0. So just like that. If I add stu of 0, and here I'm printing its value just a minute. Let me comment. Okay, location. Okay, along with this location, I want to print its value, its address. So what I'll do, let me copy this one for now. Control E. I'm putting the addresses and then I'll specify like percentage 8D just to like maintain a proper space between. Please check it out. First of all, I'm printing the value, then you can just here I have to specify ampersand address. Okay, so please check it out. These are the memory locations and these are the value corresponding to these locations. And let me put a slash n over here. Please check it out. Fine. 1, 2, 3. Okay, I have some extra spaces. That's why. 7. Doesn't matter. Okay, fine. So along with the value, let me make it minus 70. Let me check it. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. what I'm doing, I'm just performing some kind of justification, and that's it. Fine. So these are the addresses, these are the values. Now I just want to like initialize this array with some legal initial values. So what I'll do, to perform this operation again. And here I'm initializing this array. Okay, after the value, let me initialize this array. Here I'll initialize this array, scanf. Oh, sorry. Scanf %t. We'll put Q of I is equal to I into 10. Fine. What I'm doing, I'm just assigning value to these locations. Don't get any slash n over here. Please check it out. Fine. Look at this. This array was previous the addresses. This was the default value. Now I've initialized the array with some values, and this is the current value of the array. Okay. So look at this. Here we are having contiguous memory allocations. So all the data type are of same type, and they are contiguous in nature. So by this property, your array will get one more property of random access nature. Right? If the element are of same type and the data is contiguous in memory, so you can pick any element out of this array on constant time. So searching and retrieval operations are very fast on your array data structure. Okay. Just like we are having array of a number, in a similar way, we can also have array of characters. So array of characters are basically known as strings. So let me create a new source file. Okay. So str main and return 0. Okay. Now we are just going to deal with some character. So suppose I just want to store like a 5 different names in my environment. Okay, 5 different names in my environment. So what I have to do, I have to create a character array. So to hold a numeric value, we are having numeric array. If you want to hold like characters, then we need character array. So I want to store 5 names, and the size of each name will be of a 20 character, approximately 20 characters. Right? What I'm doing, I'm just creating a 2-dimension array. So this array can hold 5 names, and the limit of each name is maximum up to 20 characters. Okay. So here we are performing a static memory allocation. So if the length of name is less than 20 characters, then all that space will got wastage. So we can just utilize our memory properly with the help of dynamic memory allocation. Okay, we'll discuss this tomorrow. Okay, so now we are having an array. This array can hold 5 names, and the length of each name must be of up to 20 characters only. Okay. Now there are 2 different ways by which you can assign value to this memory location. Either you can assign value character by character, or you can assign value string by string. So when we are having a group of characters, so we are having some functions that make these operations easy. So like if you want to like store 5 different names, we can use like a getters function. Okay, getters function. Getters function just accept a character array inside it. Okay. So if you want to assign a whole name directly, so you can use getters function for that purpose. And if you want to print a name at a time, we can have put as function. Okay. Please check out the syntax of put as function. You have to pass a character pointer inside it. Okay. So now let me show you how we can just take 5 names. So printf, like %t, percentage, just the message on the screen. Enter 5 names. Okay. Now I need a loop. Look at this. Now what is the advantage of array? Instead of assign each name value individually, we can use a loop here to minimize our code. And like I, comma j. I'm using a loop. So for I want to show 5 names. So for I is equal to 0 and I is less than 5 and I plus plus. Okay. Now here we have to use get as within bracket names of I. Get as name of I. So what I'm doing, I'm just picking a name at a time and storing that name inside this array. So this two-dimension array is actually uh, a pointer of pointer. Okay, it is an array of pointer that can hold 5 different character array inside it. Okay, so here what I'm doing, I'm specifying the address of the first pointer of this name array. So this is how we can input and to print name. Here we have to use putS, which will get as putS. Printf /n of names. For run this code, hash include string. Oh, sorry, string.h. Please check it out. Okay, and the 5 names I'll mention like James, Anna, King, Blake, and Smith. Fine. List of names: James, Anna, King, Blake, and Smith. So this is like how you can perform the operation. And so this is actually character array string. Okay. Now suppose you just want to perform some kind of sorting algorithm on these names. Suppose you want to sort these names in ascending or in descending order. So we are having a lot of functions in our string header file that will help you out to resolve all these issues. For example, I just want to perform some kind of sorting operation. I want to sort the list of all these names. So we are having some functions. Let me show you one by one. We just show you some functions, then we'll apply that function on this program to sort the names in a specific order. So okay, let me save this file first. So this is strdemo.c. We already having strdemo2.c. Okay. So hash include stdio.h and the header file of string. So suppose I'm having two strings, so char st1, that the size of 10 characters, and that we assign some data inside it, like hello, and the st2 is equal to, this is how you can like initialize your array. And then first put as one, and so with there is an issue with this. There's a put function. You cannot perform any kind of formatting on your output. Okay, if you want a formatted output, you can use like a printf function. Okay, hello world. Okay, now let me show you some common operations. So you can just like concatenate these two strings. So for the purpose, we are having a function name concat. Okay, so in concat function, so you have to like specify for string one, then string two. So string two will get appended at the end of string one. You can use this percentage S symbol, okay, and st2. Please check it out. So there isn't any kind of bound checking in C. Oh, sorry, I have to specify st1 over here. Having some issues. strcat, I think. Okay, I started to look at this hello world. Whenever you want to add a string at the end of the string, we are having a strcat function. In the same way, if you want the copy, you want to copy a string into the string. So look at this. Here we are having array, and look at this. This approach is not legal. Okay, so arrays are actually the constant pointer. Once the array is assigned a memory, you cannot change its base address, right? So this operation is illegal. So my intention is to copy the data of this st2 into st1. This operation is illegal in case of array. Okay, we cannot assign a base address of array into another existing array. This is actually an issue. So if you want to copy the content of an array into another character array into another, there is a function name strcpy. Okay, so we have to specify our destination string, then the source string. So I want to copy the content of st2 into st1. So strcpy is the function for that purpose. Okay, so you cannot directly assign it. In the same way, if you want to perform comparison between two strings, we are having function name strcmp example. So you have to pass two character pointer over here. So if I'll mention like James, look at this, James. Let me put it inside a printf statement. So this function actually return a numeric output. If both the string are same, okay. So it will return 0. Look at this. Definitely you get 0 output. So if the ASCII of first string is less than the second string, it will return -1. The ASCII of small capital J is small than the small j. That's why we are getting minus. And if the ASCII of first name is greater than the ASCII of second name, you get a 1 in that case. Fine. So this function is case sensitive. If you want a case insensitive comparison, we are having a function in str case cmp. Look at this. Here case is different, but still you'll get 0 as output. Okay. And if there's a difference in names, like James, if I like Thames, now it will return the ASCII difference between T and J. Look at this. strkcmp. Fine. If I'll make it like small, and this one is big, if I run it, then we get -1. Fine. So this is case insensitive comparison. strcmp. The same way, if you want to compute the length of an string, we are having strlen, the most popular function. strlen within parentheses of what, whatever you want. You can specify the name of the array, or you can specify whole string as well. So I'll specify st2 over here. So I want to compute the length of words. So it is of 5 characters only. Okay, so 5. The same with this one more function that we can use to reverse our string. That is strrev. So we can start printf like %s comma strrev within parentheses. Specify st2. It will return a pointer, and we are printing the value associated with that pointer. Look at this. This is how you can reverse a string in C. These are very like important iterative function that you can use in our code. So we know how to perform comparison. Now I'm just going to use this particular function in resolving a problem. Look at this here. We are having names, and now I just want to sort these names in a specific order. Okay. So for sorting, we need to compare the name, and if the ASCII of name is of first name is greater than the second name, then we have to swap the names. Okay. So I'm going to use a small logic over here. So after entering the name, I just want to arrays to variable and some kind of sorting logic. So now I'm having 5 names, and I want like a temporary array that will hold the name that we want to swap. Length of this temporary will be of 20 characters only. I'm just writing a simple short logic sorting. So you can use any sorting logic. I'm just going to use like bubble short. So I is less than, we are having like 5 names. So I'll mention less than 5 and I plus plus. So let's specify another logic for like j is equal to 0 and j is less than 5 minus I 5 minus I minus 1 and j plus plus. We need to write our short logic. So if str of our array's names. Okay, there we are comparing the string, and if the name is greater than 0, okay, or what we can say is equal to 1. After comparing these two names, if the ASCII of first name is greater than the second name, then we'll get 1 as output. If it is 1, then we have to perform swapping operation. We have to write like a strcmp in parentheses. First of all, the temp array will store the name of j inside it. Okay. Name of j and the name of list of all the names over here. So here I'm using like a simple searching algorithm. And so we are getting name. Here we are like checking the name cases, and here is a case. It's a case sensitive search. So be careful. If you want case insensitive search, then you have to use strcmp. Okay, and that's it. Let me check it. whether we are having an issue in this code or not. But you just have the strcmp name of J, name of Jan. The issue, its names. In the name. Current of 5 name, if I'll mention like James, Anna, Anna, just, okay, just give me a moment here. I'm making some issues. Oh, sorry. What's that? What I've done? STRC. Sorry. Correct STRC. Now it's STRCPY. Present comparison and copy. Let me check it one more time. So it's James, Hannah, Hannah, Nina, Blake. Just here, I'm having some issue with this code. Just hold on. Please check it out. In just a minute. Now it is correct. Please check it out. There was an issue in this code. So first of all, with James, then Anna, Nina, then King, Anna, Blake, James, King, and Nina. Okay, so then the list of name is in shorted order. Look at this here. I've used some built-in function in order to perform the simple logic. Okay, fine. So as simple as that. Now, just like what I'm doing, look at this. What I can do in this case, so I'm passing a character array of 20 names. So let me show you one more thing. Let me cut this whole code from here. Okay. And I'll just create one more function. It's void. Have this whole logic over here. And two more variables. Okay. Here I'm having an array of character array of names. Fine, so let me copy dimensions. R, place it over here. Okay, fine. So I just want to pass an array. Let me check it for you. Copy this one. I'm trying to compile this code. Step. I just want one more variable. This variable is not required over here. a semicolon over here. Okay. And one more thing. Let me just show you one more important thing. Instead of this complex code, please check it out. If you want to pass an array to another function, so we can just pass an array in a similar way, okay, as we can pass another variable. Look at this. I'm having a code. Okay, an array int arr. So let me put an array of like 10 variables. The number, sorry. This is the way how you can initialize the array. 1, 2, 3, 6, 7, 8, 9. So I just want to like pass this array to another function. Okay. Void print arr is the name of array. This array except this function except you can use same name if you want. So for a small word like ambiguity or confusion, I'm just using another. What I'm doing, I'm passing the array to this function, and this array will print the function over here, detail of this array. So now let me put the prototype of function before the main first. This is the prototype. Function is accepting an integer pointer, and the name of array is actually the base address of that particular array. Okay, let me show you. If I write printf %d %d and I'll specify ARR. Okay, so whenever we print the name of an array, it always returns the base address of that particular array. Let me show you. And giving 10 elements and I press this. Rounding, I'm just trying to print the base address of this array. Okay, address of this array %d comma. I'm printing the array. After that, I'm printing the address of all the elements of array. And ARRDEMO 2.c. Oh, and just want to print %d ampersand of ARR5. So I saw it. Please check it out. Fine. Okay. So the name of array and the base address of the first element is same. Look at this, right? So the name of array actually points the base address of this array. Just remember this point. Okay. Now let me comment it out for now. Okay. Now what I'm doing, I just want to pass this array to a different function. Will I print all the values of this array? Okay. These two statements. That is after like creating the array, I just want to send this array to this print array function. So here what I'll do, I'll just write print array, the name of the array, then the name. Fine. So ARR, that is what I'm doing. I'm just passing the base address of this array. And to hold address, we need a pointer variable. So pointer here is a pointer variable which is pointing to the base address of this array. Now you can use this pointer just like an array. Pointer and array are like most of them are similar internally. Okay, difference that pointer can hold different memory addresses, but the array can hold only one address inside it throughout its lifetime. So the difference between array and pointer. So pointer variable can refer to multiple memory address throughout its lifetime, but the name of array can point to only one memory address throughout its lifetime. or we can say the base address, the address of an array variable cannot be changed, whereas the address of a pointer variable can be changed. Okay, this is the only difference. Now error 0, and here what I'm doing, I'm passing this array. This ptr is holding the base address of this array. Now I can print all the element of this array just with the help of this pointer. So you can just try it, printf like a %d, %d. I'll put a space afterwards, and I'll write ptr. Look at this. I'm using pointer notation, array notation. Sorry, so I'm treating this pointer just like an array. Fine. So if you run this code, definitely we'll get the value of all the array element in a different function. Please check it out. Fine. So this is how we can pass an array. Okay, and if we are having a 2-dimension array, so let me reduce value by 1, and let me make a 3x3 array over here. For the clarity, okay. The first row of the array, second row of this array, and the third row. Visualize this array in this way. If the array is single dimension or multi-dimension, doesn't matter. The memory allocation is always contiguous. Okay, look at this. We are having a 3x3 array. I just want to send this array to a specific function, to this particular function. Here, along with this array, we have to specify the number of elements in this array. No worries. Okay, passing an array. And here, what I'm doing, I'm just I'll just retrieve this array over here. So to hold, so what I will do, I'll just pass a pointer that will able to hold a numeric array of 3 elements. What I can do, I can just create a pointer to an array of 3 elements. Okay, so this is how we can just make it. Pointer to an array of 3 elements. That means this pointer can point an array of 3 elements only. Fine. So it's a pointer to an array of 3 elements. Okay. Now here I'll use I and j, 2 variables. And we know that we are having 3 elements in each row. So I'll just create a nested loop. Price equal to 0, here j is equal to 0, j is less than 3, and j plus plus. I'm just going to iterate this array just like a 2-dimension array. Please check it out. To print the data in matrix format, I'm just using this logic. PDR of I of j. Okay. So what I'm doing, I'm passing an array to this function, and now to make a small change over here. Okay. Let me check it out. Star PTR and changing it. Save this one and run this code for now. Okay, look at this file. So this is how we can pass a 2-dimension array to a function. If you want, you can like specify the size as well. You can pass the size of I and j. So we can pass like 3, 3, so 3 is I and 3 j. Mention int I, int j. Okay, or like we can say this is x and y. Mention like x. You can use this approach as well. So I is less than x number of rows, and j is less than 1. In substitution, you have to pass the size of your array to the function as well. Just a minute. Let me make some small change in this code. Now int comma int. You have to change your prototype accordingly. And just we have a small issue here. Okay. Just let me check it. Comma. Okay, this fine. This is how you can pass a single dimension, multi-dimensional, undimensional array. Okay. So I think that's enough for the day. So we have discussed some basic concepts of array, loops, and string. And tomorrow we'll have a discussion on pointers, and we'll work on structures and dynamic memory allocation. Okay, so thank you so much. That's all for the day. So tomorrow is the last day of our training program, and there are few contents that are left that I'll covering. The first is the pointer, and we'll discuss the arrays. Oh, sorry, not arrays, structures and union. Thank you so much. That's all for the day. We'll meet tomorrow at the same time. Till then, take care. So you all can leave the session for now. So I'm turning off the session. Thank you so much.